Hey everybody, welcome to today's session on evolving Compose Multiplatform on iOS and beyond. My name is Sebastian. You may have seen me earlier today or in some other contexts, and I'm very excited to spend the next 45 minutes or so giving you a little whirlwind tour of all the changes that we've made in Compose Multiplatform ever since we last talked about it. Because it was actually just 1 year ago where we stood on stage and we first talked about Compose Multiplatform on iOS and some of the other platforms for the very first time. And of course, this was a really exciting time for us because with Compose Multiplatform, we really managed to take the Kotlin multi-platform story to its natural conclusion, right? Rather than just being able to share business logic with Kotlin multi-platform, you are now also able to share your UI elements, not having to do them over and over again, but instead being able to share them while still using the platform capabilities even on the UI layer. And of course, it's a pretty exciting time right now because the stabilization journey for Compose Multiplatform is in full swing. On Android, when you're using Compose Multiplatform, that just decomposes, no pun intended, right into Jetpack Compose. So here, that's naturally already stable. On desktop, we've been stable for a whole while, and if you've ever used JetBrains Toolbox, then you have actually used a Compose Multiplatform application on desktop yourself. And as you saw earlier today, we have promoted the iOS target for Compose Multiplatform to beta since just earlier today, and with the Compose Multiplatform 1.6.10 release, and we've promoted the web target to alpha. So it's a great time to kind of see what has happened since we last checked in with Compose Multiplatform. So today I want to take a look both at some of the iOS-specific changes that we've made, but also talk about the general common APIs that we've introduced that are actually available on all Compose Multiplatform targets. We really hope that those are going to be very useful for you. So last time we went up on stage, we were very upfront about the fact that there was still a lot of work to be done, and across multiple sectors, right? From things like how you actually interact with the application, all the way to how you implement navigation, how text selection and input works, and of course also topics like accessibility. Now, I don't have a lot of slides, nor do I have a lot of transitions, but this one I think is my favorite. Since the last time we spoke about it, we have made progress in literally every single one of these areas. We have either fully implemented the functionality that we set out to do, or we have provided something that has made significant progress and that you can already use, or we have at least an experimental version that you can try out and that we will continue stabilizing over the coming future. Now, when I showed this slide to a colleague, he rightfully noted that this does not actually reflect what happened. This is closer to what it actually looks like. The vast majority of things are just done now, which is very exciting. And a couple of other things are still a work in progress. We can start out with subjects like accessibility. Now, iOS has a very strong accessibility system with VoiceOver that doesn't just include text-to-speech, it also includes a full gesture navigation system that's specifically designed with accessibility in mind. With the newest versions of Compose Multiplatform, out of the box, your components behave correctly when it comes to the accessibility hierarchies. Given that you provide content descriptions for your images, for example, those also show up correctly if you look at them using the accessibility inspector or just enable VoiceOver on your device. So all of these features are actually available out of the box. We've also revamped scroll physics so that they essentially exactly mirror the scroll physics that iOS users are used to, including overscroll and spring physics, which just provides you with an even more native feel when you're using Compose Multiplatform. And we've also introduced new interop functionality. For example, if you're mixing Swift UI and Compose, then even if your Compose part only takes a small fraction of the screen, if you have, for example, pop-ups or dialogues, those can still stretch through the entirety of the screen by being rendered on an entirely separate layer. We are also making a whole bunch of progress here, and we made a bunch of progress to make sure that you can use the entire real estate that the screen of iDevices provide with the new changes to insets and cutouts. So what you can essentially just do is you can go into the Swift code that calls your Compose code for the first time. You can turn off the safe areas to make sure that it actually renders across the entire screen. And then from there, you can use the common Windows Insets API to make sure that all your elements are placed correctly on the screen. If you've done Android development with Compose before, then you will have seen these window insets padding functions before. For example, you could use system bars, but we've actually ported an entire library of these to make sure that they're also available in common code, which means your applications can look great, whether they're in landscape, whether they're in portrait mode, and whether that device has like an island, a magic island, or a notch, or whatever Apple might come up with next. Cody's face is, of course, optional. We also introduced a new common UI testing API, which allows you to now write UI tests once and then execute them across all the targets you have with Compose Multiplatform. What this could look like, for example, here, we have a tiny composable. All that does is put some text on the screen that is supposed to be prefixed with info. I'm not very good at typing, but rather than relying on Grazi or some other grammar tool, it probably makes more sense to actually write a test to ensure that this thing actually does what it's supposed to. So in this case, for example, we could just run a Compose UI test that takes a lambda. Here we can set up a bunch of composables. In our case, that would be our info composable. Because this is a very simple one, I'm just injecting a test tag here to make sure that I still have an opportunity of easily finding it. But of course, there's also other ways of traversing the Compose hierarchy. And then I can just write an assertion to make sure that the text actually contains the substring info. When you run this, for example, in Fleet, but wherever, you will, of course, then get a failed test, and you will see exactly what it is that you've done wrong. But we are also making a whole bunch of other libraries multi-platform. That includes common resources, it's lifecycles and view models, and it's also navigation. And all of these are available either as stable with resources or as experimental with lifecycle, view models, and navigation for you to try going forward. We can first take a brief look here at resources. Essentially, what we're providing you here is something that, once again, you are most likely already familiar with. We're providing you type-safe accesses that you can just access using the res object rather than the R class that you might be used to from Android. And then in your common main source set, you can just throw in a Compose resources directory and put your files in the appropriate subdirectory, like drawables, files, fonts, and values for strings. Let's actually take a brief look what that looks like in reality. So I can just hop on over here. I am in JetBrains Fleet. I'm just in a small little demo project here. Let me make sure I close this. We are, of course, in the common main folder, so we are entirely in platform-independent code here. And I've made sure, thanks to the wonderful pre-flight checks, that my development setup is actually set up correctly. So let's hop on in here, and let me also make sure that I have my other files ready over here. And here we just have a very small application. I can actually just briefly run the preview here to give us a bit of an idea of what this code actually does. As you can tell, very little, not very beautiful. What always makes things a lot nicer is when you throw in some graphics, or if the text is maybe slightly more descriptive than just some text. So we can do exactly this. We can hop on over into our common main folder here, and let me just copy a file. We can go into common main, and we can grab ourselves a compose resources directory. And in here, we could create our drawable subdirectory. I'll just throw in a file. I guess I did not copy that correctly. Give me 2 seconds. There we go. Okay, so I've moved this in here now. So what I should be able to do is, rather than just draw a box, is I should be able to just draw an image. This one would use a painter resource, and then I can use this res object. We're looking at a drawable, and I added a banner here. And of course, we'll also provide some content description. And within a couple of seconds, we can see, hey, it's Kotlin Conf. One of the things that you probably, thank you very much. Everyone loves Kotlin Conf. One of the things that you probably noticed here was that I didn't actually have to do any like reloads or anything like this. That's because Fleet does have integration for Compose resources, so it actually detects the moment I move new files in here. It automatically regenerates all these type-safe accessors. Otherwise, if you're using a different IDE, you could just use the generate compose res class Gradle task. That would do the exact same thing. Here we just get a little extra convenience. Okay, some text is still a little nondescript, so maybe we can also throw something in here. Rather than just having drawables, we'll also have a values directory. Now, I do have some strings already prepared here, just so that we're not just looking at a single lonely string. So let me just create my strings.xml over here. This is just from another sample project. But we can, of course, also create our own string here. This follows the same conventions that have already been established in Android development. So, for example, here we could do our conference description. Just close this for a moment here. And we could, for example, say, well, we are looking at some sort of conference. And we can then hopefully inject this part. So moving back over here, we can just grab ourselves actually the string resource. And in our case, that would be res string. I believe I called it conference description. Is that what I called it? No, I got it. But thank you. Appreciate it. So once again, looking at this, well, without a placeholder, I don't think we're currently at a %1 conference, so maybe this is a Kotlin conference. Just have this reload for a second. And hey, that looks a little bit better. Some might even argue that this is now a multi-platform conference. Who knows? And of course, we can see that one as well. Now, of course, you can also actually parameterize your resources, right? So rather than just having some values here, what I could do is I could throw in another directory called values.de. I'm naturally a German speaker, so this is the only translation I could reasonably create. I could just throw all of my resources into this directory and could then start translating these. I guess what I can also just do is just ask AI Assistant, and if the conference Wi-Fi works, we'll see. We'll see. Oh no! Well, I guess that's my fault, isn't it? Should I do the hotspot or should I be? I can't even see the Kotlin Conf one. There we go. Let's try that one more time. There we go. Zurück looks good. Cupcakes looks good. Ein Cupcake looks good. The eine Konferenz also is perfectly formulated. Look at that. So, of course, my entire setup that I have here on my desktop is actually in English, but if you take a look here and you look at Dateien, Kurzbefehle, and a couple of other great names that I have here on my iPhone emulator, you'll notice that that is indeed in German. So the moment I actually run this application on this iDevice, so suspenseful every single time. It is indeed eine Multiplattform-Konferenz. Wonderful. I don't want to stretch the demo on this part too much, but I do also just want to note that you can also use plurals, and AI Assistant does write these correctly. Does it? No, it actually doesn't. Ein Konferenz doesn't. Well, you know, I guess we still have the upper hand over the robots just for a little longer. But of course, the APIs exist, and you can absolutely use those. Great, wonderful. So as I said, you actually have a bunch of different ways that you can specify what your resources should look like. You can do that by type, you can do that by language or region. You can also throw in the theme as well as the density. Not sure why my cursor keeps on sticking around there, but that's okay. All right. For example, if you look at a German dark mode drawable, that is what I would imagine that would look like. Has gone through great user testing. We also support multi-module resources if you're on Kotlin 2.0 plus, which means you can create libraries or you can create separate modules for your applications, and you can throw resources in there, and they will also resolve correctly. So as somebody who's a big fan of throwing a bunch of different emojis into like all of my slides and like all of my applications, I do hope that we'll see a lot of different emoji flavors, maybe open emoji and so on, packaged and ready for use in Compose Multiplatform. Okay, so let's continue and let's talk a little bit more about our lifecycle implementations. First of all, the question maybe arises, why do we even need a cross-platform lifecycle? Well, generally, lifecycle abstractions are really useful because they do help you build more robust applications. Why? Because if you or your code can understand in what phase of the lifecycle your application is, you can stop doing unnecessary work. You can avoid doing these kind of things. So this is one of the typical charts that you might be familiar with. If you're a mobile developer, you have a bunch of different states, and then you have a bunch of different state transitions. On Android, those are just the things that you would get out of the box. We have actually gone ahead and we have mapped the iOS lifecycle events onto this same lifecycle model. So things like view will appear, will enter foreground and background, as well as view to disappear. We have just kind of essentially hooked up together here. Again, these are actually common, so they are usable not just on iOS. We also have implementations for web. There it's particularly easy because the life cycle of something running in the browser is usually it's either there or it's not. On desktop, we also have a couple of mappings. We're not going to look into those too closely right now, but they're all available in the Kotlin multi-platform development documentation. So let's have a quick look at a tiny little demo of this one. It'll just be a very quick one. So we will just quickly open up my lifecycle app over here, and we can take a peek inside. This application does very little. I've added a lifecycle logger, which is a custom composable that I've created. All that does is it looks at the current lifecycle events and the current lifecycle state and just prints that to the console. And the other thing that I have in my lifecycle app is I have this cold flow that I can now, in common code, collect using collect as state with Lifecycle. I know that there was a bunch of like Reddit threads and so on for people asking like, hey, when should I use collect as state and when should I use collect as state with Lifecycle? And the like common wisdom was always, well, if you're doing multi-platform, you can't do collect as state with Lifecycle. We've finally caught up here, so that wisdom no longer holds. Okay, so we can actually take a brief look here. You can see that as the application starts, we get into the resumed state by going through onCreate, onStart, and then onResume. And you can see that our little collect as state with Lifecycle is indeed running. Now, as I move into the app switcher, we get an on pause, putting us into the started state. If I just were to go back, we just go straight back into being resumed. And of course, if I just navigate out of the application back to my home screen, I get an on stop, which puts me in created. By default, when you're back in the created state, things like collect as state with Lifecycle will cease its operation. So you can actually adjust this just by kind of like having a look here at the overload. You can see that there's a min active state. That one determines when the collection should still happen. But it would now be reasonable to assume that as we navigate back into our application, the flow gets collected again from the beginning. So it starts again from the start. Cool, great. So with that, what we have seen, or the main takeaway here is, look at that, we have a collect as state with Lifecycle as common code now. Woo. Cool, so now let's talk a little bit about view models. Why do we need view models? Well, of course, I don't want to be super prescriptive here. If you have other architectures that are not MVVM, you are welcome to do those. I have no horse in this race, but they are indeed a very well-established stakeholder abstraction for a lot of mobile developers. They obviously encourage unidirectional data flow where you have your UI emit events into your view model and then that view model updating internally. And of course, they very naturally integrate with the lifecycle abstractions that we've seen prior. Plus, they play a special role on Android with the whole survival of configuration changes, activity recreation. Fortunately, you can rotate an iDevice and nothing bad happens. So we don't actually have to care about that one if we're working in common code. I suppose you can also rotate a web browser and nothing will happen. I don't know what that would look like in practice. So we're actually publishing these as two different artifacts. We have the lifecycle view model under the org JetBrains coordinates, and that's actually a common view model that is Compose independent, right? So that's just the view model abstraction that could also be used without using Compose Multiplatform. And then we also provide lifecycle view model Compose, and that provides you with things that allow you, for example, to scope a view model to a nav graph or just to instantiate it using these kind of factory functions. Okay, so let's actually take a look at what that might look like in practice. So I'll just grab myself my view model demo application here, and we can actually just take a quick look. On paper, this is once again a very simple application. It just has 3 buttons for your current mood that I guess you could log. For example, happy, neutral, and sad. And then you probably want to store that somewhere. Unfortunately, that currently doesn't do anything. And this is maybe one of the classic cases where you would want to outsource this change mood logic as well as this kind of counter that indicates how many mood changes you've stored. You probably outsource that into a view model. So let's actually have a look here and move over to my very empty mood view model. We can just once again start with a little bit of a scaffold. So we'll just do a view model with a state flow of change count and we'll call this one, we'll implement that ourselves, and a to-do store change function. That looks pretty good. Hey, look at that. And once again, here you can see the power of Compose Multiplatform shine again. Because, once again, I mean, these APIs were out there on Android for a whole while. So all those fancy LLMs, they kind of know how to write this code. We're not really inventing anything new here. Of course, once again, we can prove that we're better than the machine. I personally prefer wrapping this in as state flow so that you can't do the downcast. But that's pretty much it. Interestingly enough, unlike in my rehearsals, the wonderful AI has decided to give you a little bit of a spoiler here because, of course, one of the main reasons why we enjoy using view models is also because they provide us a view model scope for doing suspending operations. So in my case, for example, I could go into my repository, I could save whatever my current mood as a string was, so I could do that, and then I could make sure that I actually grab my underscore change count and I update it by incrementing it by 1. Okay, cool. Of course, our view model is not used yet, so we will go back to our view model application here and we'll create one. Our mood view model can just be created by using this factory function. This is a slightly different factory function than what you might be used to from Android. You might be using it usually to, or you would refer using the : class. There's a small limitation in Kotlin native that doesn't allow us to port that API, but to be fair, I don't think this is a whole lot different. Now we can just wire up our change mood function. So in this case, that would be just storing the element, and we can grab ourselves out of the model the actual state. And once again, we can collect it as state, not just generically, but even with Lifecycle. And that's pretty much all the changes we had to make here. I did create a little lambda function here for change mood, just so that I don't have to change this in 3 different places. But of course, it would have worked otherwise as well. And now, as we click things, we can first of all also see that we're saving happy to the database. And as I keep on clicking this, I have a very hard time right now being here at KotlinConf clicking anything that's not happy, to be quite honest with you. But yeah, so this also works just as you would expect. Great. So yeah. The way that you work with view models generally is you can just have the view model constructor function that uses the curly braces rather than the round braces and class. And of course, if you have a dependency injection framework that is actually aware of Compose Multiplatform's view models, then you can also just use that one, of course, to retrieve your view model. Now, of course, we're standing here, right? And we've announced all of this stuff earlier today. So how could there be a dependency injection framework that already has support for this? Well, thanks to the absolute lightning speed adjacent work of the folks at Coin, they actually already built an implementation of this against our previous RCs. So if you use the latest beta version of Coin, you can already use it with Compose view models to inject them, which I think is pretty cool. If you see Arnaud around during the conference, make sure you thank him for this excellent work. Okay. Somehow that applause even feels better because that one doesn't feel like it's for me. So let's also still talk about navigation. And in general, once again, what we're doing here is we are bringing Jetpack navigation to common code. I once again want to stress that that just means that you have one more choice that you can make when you're picking a navigation library. The Compose Multiplatform community has actually been very active ever since we've done the first public releases for building really cool solutions. This is just one more solution. The reason why we're bringing this is because these are very well established and quite popular APIs. So if you're building an Android application that is using Jetpack navigation, this just makes it a whole lot easier to bring it to multi-platform. Okay, so because all of this actually also ties in with view models and with Lifecycle, this is kind of our little capstone project here. So we're hopefully putting everything together that we've seen so far in our navigation demo app. Okay, so our task is pretty simple. We have an individual start page over here. We can take a brief look at what that will look like once we actually build it, which is just a list of a whole bunch of fruits. And then for each of these fruits, we have a specific subpage, which first of all has a little note section where we can just write a bunch of text. And it also has a related fruit navigation section so that we can go to some other fruits. Before anyone says anything, I looked it up. Avocado is technically a fruit. And of course, we want to have some sort of stack-based navigation here. So let's actually go ahead and start constructing this here. We will start, of course, just in our entry point of our application. Need a little bit of extra space. Generally, in the Jetpack navigation library, most things start in the nav host, and then we can just kind of start filling this in. It requires a nav controller, so we can create one of those just using the remember nav controller function. So we can fit that one in here. It typically requires a start route, and then it also requires a lambda in which we can provide some composable routes. For example, we already know that our start route is this specific start page. We also want to make this slightly nicer. So what we can do is we can throw on a modifier, which first of all, let's see here. We probably need to make sure that we use the window insets padding. In our case, those would be, again, we try to remember here something like, hello, IntelliJ, good to have you. I know you want attention. We can just do the save content here, and we can also just make sure that this actually fills the maximum size. Just to make this a little bit more visual, I did also prepare a couple of transitions. These just kind of like provide a nice little stack animation so that we can actually see what's going on rather than the default crossfade, but that's not actually strictly necessary. Okay, rather than just printing out that we clicked on a fruit, we actually want to grab our nav controller and we want to navigate to a different route. For example, the fruit form that we're working on with a specific fruit. Of course, we should actually use the real fruit that we're getting back here. We should probably also construct that route, otherwise we'll not navigate anywhere. So in this case, we will actually use this placeholder syntax, and we know that with our fruit page, we have a couple of parameters we need to provide. The current fruit, that one we probably need to somehow extract from this route. We can actually see that we have access to this backstack entry here using it, but we can also give it a name. Call it backstack entry, and we can see here, okay, we have the arguments, and then in there, I think I can just call getString on fruit. Otherwise, we'll say this is no fruit, and I really hope that we won't hit this case during our little demo. Okay, so now we know what the current fruit is. It's just fruit. When someone selects another fruit, so when we have onSelect fruit, we once again want to do something that looks pretty similar to what we've done up here. But let's make sure we actually navigate to the correct fruit that we wanted to have. And then we also have an onBack. That's just the back button that we already previously saw. So in this case, since this is all a stack-based navigation, we can pop the backstack. And I also have just a tiny bottom slot that I can use to create some breadcrumbs. Those will just help us visualize what it is that's actually happening. Okay, so with that, I believe most things should be in place for our application. So let's take a peek and see what I forgot. Maybe I forgot something. Who knows? We're all learning together. That's the beautiful thing. Okay, so we have our list of fruits here running on my iPhone. I can scroll up and down. I am technically a developer advocate, so avocado, that's close enough. You can see here that actually this is something we didn't quite discuss, but each of these screens also has an associated view model that does a couple of operations. In this case, it just grows avocados. You can see that not just on the screen, you can also see that over here in the terminal. So you can see that these operations keep on running. Now, as I click on the apple, you can see that the avocado view model is still on the backstack, right? So that keeps on running in the background, but now we're also seeing all of those wonderful apples. And of course, as I continue here, you can see down in our little breadcrumbs visualization, very small, that we are indeed kind of creating this little backstack here. So as I navigate back, we can actually see that each of the individual view models are cleared step by step. So those operations stop until we arrive back at our main application, which already looks pretty good, but there is still a couple of issues here, right? So for example, I'm an avocado. Seems like a note that I should be able to remember. It's also important to remember that this keeps doctors away, right? And at Kotlin Conf, I'm going bananas. But the problem is when I go back, those are gone. And now I don't remember whether I'm an avocado anymore. Of course, this was just one of the classic problems that you will encounter if you use the remember function by default, because remember, when your composable leaves the composition, we'll also forget the state. But with the navigation library also acting as a place where you can put savables, you can actually change this to remember savable. And if we run this same application once more, we should hopefully make sure that all of our important notes are actually stored. So once again, doctor away. Life gives lemons. Kotlin conf equals bananas. If we go back, still there. Look at that. Absolutely gorgeous. And of course, all the things that by default have some sort of remember savable inside their implementation. For example, this scrollable list. If I go back here, you will also see that it does remember the scroll state. So the avocado is still visible as I navigate back, even though it's actually by default scrolled out of view. Great, wonderful. Seems like we've built an amazing application here. Great, so yeah, as you can see, there's a very natural synergy between ViewModel's navigation and Lifecycle. Those all fit together quite well. One of the topics we didn't talk about today, just because of time limitations, is also that we have support for things like dialog destinations. And of course, we're continuing to integrate this experimental library with things like deep linking, so that someone can actually click on a link and get sent to a specific screen inside your Compose Multiplatform application on iOS, as well as common backhandling. You also saw me type a bunch of strings and routes and all these kind of things when I was actually setting up my navigation. One of the very exciting things is that the Compose navigation library actually is getting type safety. And of course, that is not an Android-only thing. This is all being built on top of Kotlin X serialization, which is a multi-platform serialization library. So we're getting support for that in Compose Multiplatform in the near future as well, so that hopefully you will make very few typos, or if you do make them, the compiler will yell at you. So with that, both building Compose Multiplatform applications and also taking existing Jetpack Compose applications on Android hopefully becomes a whole bunch easier for you with these new steps. It's also really exciting because, of course, Jetpack Compose itself also keeps evolving, right? We've seen today in the keynote that they're introducing the new strong skipping mode, and you can already activate this as an experimental feature in Compose Multiplatform as well, and really cut down on some unnecessary recompositions in your multi-platform applications. We're also getting support for the shared element transitions and lazy list animations that are coming with Compose 1.7, and you'll be able to build some really cool-looking UI using that. And of course, the stabilization journey continues. We continue to refine these things, and of course, we do that based on your feedback. So here is my call to action for all of you. Please go ahead and try all this new stuff that we saw here with your applications, because once again, we evolve this using your feedback. The easiest way to get started is to go to jp.gg/compose. And from there, in less than 3 clicks, you will end up on this page. I will leave this as an exercise to the reader as to how you get there, but we actually do have documentation for all the features we talked about. So once again, if you want to look up those lifecycle diagrams that we saw here, as well as like all the modifiers, the modifier order and precedence for common resources, and some more details for cross-platform routing, you can do that on the multi-platform portal, where you also see a whole bunch of other information. Yes, because Compose evolves with you, it is really important that if you do find something that doesn't behave the way you want to, or where you're like, wait a second, that doesn't seem right, that you do log a couple of issues for us. You can do that in our issue tracker. And of course, we have a super helpful community if you're looking into these things on the Kotlin Lang Slack. So make sure you stop on by there and maybe say hello. Now, again, the wonderful thing about Compose Multiplatform is that I'm not really telling you a lot of new things. All of this are established libraries. So as you go through the rest of KotlinConf, and if you go to any of these talks, there's a good chance that you can map them one-to-one to Compose Multiplatform as well. Some of these are case studies that happened earlier today. So either you have a time machine, or you can use the recording feature. Of course, all these talks are recorded. Of course, we would love to send a couple of you folks also to Arnaud's talk on Coin. After all, they've done some really exciting work here. And this is, of course, the place where I'll also plug the talk from my colleague, Elijah, who's going to talk on what we do to make sure that your Compose multi-platform applications run really smoothly on iOS devices. So here, if this talk was very much like API surface, and you saw what you can do, this one is really going to dive under the hood and into the nitty-gritty details of what happens. So if that's something you're interested in, maybe take a look. With that, all I can say is I hope that you go ahead and enjoy Compose Multiplatform. And of course, don't forget to vote using an application built in Compose Multiplatform. Thank you very much.